Greetings of the day, everyone who is watching this. I'm Neha Makol. I am a PhD student from University of Delhi, India, and I'm here to present our work on green hydrogen, understanding techno-commercial viability for industries in India. I have done this paper under the guidance of my supervisors, Dr. Puja Gupta and Dr. Meenakshi Mital, who are also from University of Delhi. They are professors at Department of Resource Management and Design Application, Lady Irwin College, University of Delhi, India, and Professor Syal, who is a professor at Michigan State University. So this is our paper done together. I will be the presenting person today. I will very briefly take you through the introduction just to set the context for my research work, followed by to understand the rationale and why this paper was necessary and was undertaken. And then followed by the objectives with which this study was conceived and the key discussion points and some recommendations as the conclusion of the study and suggestions from the authors. Starting with just a very brief introduction. So, as we all know, India has pledged to become a net zero country by 2070. The journey to net zero is not going to be only led by the country, but a lot of consumers and the corporate consumers are going to play a very big role in this decarbonization journey. Corporate consumers themselves have pledged to net neutrality or carbon neutrality by 2030, which is a little early than 2070, which makes it very important for them to find tools to decarbonize and move towards a low carbon pathway of business operations. They are also receiving a lot of pressure from stakeholders, including customers, their investors, and other competitors also to go to the low carbon route and decarbonize their business operations. So, in the search of the decarbonization tools, green hydrogen is emerging as one of the most powerful tool to reduce emissions. There is a lot of noise, there's a lot of talk around green hydrogen, there is a lot of buzz. Everyone is talking about the potential that of green hydrogen that it holds to reduce emissions, and that's why it is very important to understand that how green hydrogen can help industries to reduce emissions. This is not the first time that hydrogen is being considered as to be used in industries. It has been used for decades, but it is now that the renewable power is available at a low cost, which has made green hydrogen again the talk of the town, or hydrogen again the talk of the town. Industries account for more than 65% of emissions in India, and that's why it is very important to focus on the use of green hydrogen within industries. And there is a need for a tool to reduce emissions, especially in those sectors which are very desperately looking for ways to decarbonize, which are the hard to abate sectors, or which are very emission intensive sectors like refineries, steel, aluminium, cement, and fertilizers. And green hydrogen has the potential to be used across all these industries because of its versatility as a fuel. Um, Right now, India uses about 6 MMT of grey hydrogen, which is produced using coal or natural gas. And there are two key industries, fertilizers and refineries. Fertilizers account for more than 50% of the hydrogen consumption in India, and the rest is refineries. So, which is why these two sectors are the primary focus of the industry at the moment. When I was talking about the versatility of the fuel, just to really understand that what's the significance in the use of green hydrogen and the importance, the big role that hydrogen is going to play in the coming times is to look at that how across a wide variety of sectors it can be used. It can be used as a fuel for transport, in long distance haul transportation, as a sustainable aviation fuel, even in marine, even in shipping. It can be used as a fuel for transport across a wide variety of transport sectors. And it can be also used as a heating source for industries like steel, cement, paper, food, aluminium, and also as a heating source in buildings, including residential and commercial. Besides that, like I was saying, it can be used as a feedstock for fertilizers and fuel refining. So it is used essentially to clean the diesel and the petrol in its true form, and then it is converted into a more cleaner form, which is a desulfurization process for which hydrogen is basically used. It can also be used in other product industries like metallurgy, food, glass, and steel. Even hydrogen can be used as to store power. So, which is why, because when we are looking for different battery storage or storage technologies that we have, like for example, pump storage, battery storage, hydrogen can also be used as a form of storing power in the coming times when it becomes more viable. But right now, the focus of the industry is to use where it makes the most commercial and technological sense. Um, Considering that the role and considering the role that green hydrogen would play in the coming times, and also to understand that India is the perfect place for renewables. It has the low cost advantage, and it is also considered to be as one of the most attractive places to produce renewable power. So because we have the advantage of low cost renewable power availability, India is looking at green hydrogen in a much more bigger way than other countries are looking at it right now. I would say in a comparable way as US and EU and UK is looking at, and just considering that the role that green hydrogen would play in decarbonization, India has set a very ambitious target of 5 million metric tons by 2030. And that would require a substantial amount of renewable capacity to be built by 2030, which is around 125 gigawatts, and about 40 gigawatt of electrolyzer capacity. And in order to give this sector an initial boost and initial momentum, there are several other initiatives like National Green Hydrogen Mission that I just spoke about, subsidies for hydrogen production and electrolyzer manufacturing. Also, the notification of the green hydrogen standards as to say what would be called as green hydrogen has also been notified in India. And there is a very long, comprehensive, long-term, short-term, mid-term R&D plan also being put together, which will cover the entire value chain of the hydrogen from production to the end use and end application. And there are various other incentives also available for green hydrogen and green ammonia across different states like UP, Odisha, Gujarat, Uttar Pradesh, and there is also special incentives for the renewable power which will be used for producing green hydrogen and green ammonia. So just if you look at the initiatives that there are being taken to promote green hydrogen, really talks about the importance of this fuel in the country at the moment. Um, so to understand that, so just with that in context, and to realize that the corporates are very serious about decarbonization, they're looking for financial, attractive, and technology mature tools. It became very important for a study like this to understand what is it very viable? Is it commercially attractive for the consumers to replace their existing fuel, which is really which is produced using the conventional source of energy, which is typically coal or natural gas. It has to make commercial sense. It has to be technologically viable. So the study like this was important to understand at the current status of the green hydrogen in the market, the current market status, what are the challenges related to technology and economic viability, what are the initiatives which are available by central and state government, and what would be the potential impact on the sector and the cost of green hydrogen if it becomes if it is viable or not. And in the end, understanding the scenario, understanding the understanding their viability would help to provide some useful recommendation to policymakers that can help provide a boost to green hydrogen sector. So to do the study, there was we had referred to several journal papers, a lot of past research that has been done. We looked at extensively the documents that have been issued by the government, the policies, the regulation, the discussion papers. Like I was saying, there's an extensive R&D plan, the orders issued by central and state government to understand what is the government initiatives and the policy environment and the regulatory framework that is available right now. A lot of past studies, magazine articles, news publications. And then we also spoke to multiple corporate consumers and other stakeholders in the value chain to augment our understanding and validate our findings. So just the key discussion points that I will be discussing today, starting with the very basic, the very important is the technology viability and the technology readiness. So right now, there are multiple technologies available in India. There is absolutely nil manufacturing capacity available in the country as of now. A lot of announcements have been made by multiple companies, by the likes of Adani, Reliance, who are going to build manufacturing capacity in India. But right now, there are no technologies available. There's no capacity available in India. So everything, all the technology of related to electrolyzers would have to be imported. So to look at so we are not really looking at the Indian market right now. We're looking at the global market, typically China market, which usually are providing the electrolyzers to Indian consumers who are looking for electrolyzer technology. So there are multiple technologies which are available. There is first is the alkaline electrolyzer, there is PEM electrolyzers, and there is solid oxide electrolyzers. So alkaline electrolyzers are the most commercially and technology viable alternatives technology right now. The efficiency is high, to use about 48 kilowatt hour to 64 kilowatt hour of renewable power to produce 1 kg of hydrogen. If we compare it with PEM, it is roughly around the same, but solid oxide electrolyzers uses the minimum amount of energy, minimum amount of renewable power to produce 1 kg of green hydrogen, which is why solid oxide electrolyzers are one of the most efficient in that respect. Coming to the response time, which is a very important part of electrolyzer technologies, is how quickly they react to the ramp up and ramp down of the renewable power. So, as we all know, the renewable power is highly intermittent. So, the intermittency of renewable power, the constant fluctuation of the renewable power has to be adapted by the technologies very well. So the alkaline electrolyzers have a response time of 1 to 10 minutes, and sometimes more than that also, to switch on or to switch off. But PEM is very adaptable and very flexible in that sense. It uses it reacts in less than 1 second to any fluctuation, which is why it is the most ideal technology to be used for renewable power because of its intermittency. Solid oxide definitely has a much more longer response time. In terms of technology maturity, right now alkaline electrolyzers, there's a vast manufacturing capacity available in the world for alkaline electrolyzers because of the sheer cost advantage it has over the other options. It is commercially much more viable because of its non-dependence on rare metals. So PEM are extremely dependent on rare metals. They require very precious metals, and which is why the cost part is very high. The cost of PEM is very high, and the solid oxide is only in the laboratory scale. The cost is unknown right now. There are a lot of R&D working around the solid oxide electrolyzers, but it's still being considered as one of the most attractive technologies because of the highest efficiency. The lifespan part, alkaline electrolyzers, because of their maturity, and there is a lot of R&D already done, the technology is much more viable. There is high maturity, so the lifespan is also very high as compared to PEM and solid oxide. The capex is definitely lowest for alkaline as compared to PEM and solid oxide. So if you're looking at right now, if any consumer would want to look at any technology, alkaline is coming out to be the most techno-commercially mature, and then followed by the PEM, which is definitely much more reliant on precious metal. And there is a lot of technology and advancements required for PEM as compared to the others. But PEM, moving on, would definitely become one of the main technology to be used across industries because of its response time. Because when we are talking about renewable power, it is definitely much more expensive to invest in battery storage or any kind of storage application, so that you have as a reserve of power to be used, and to constantly use the technology to use electrolyzer would only make sense if there is a battery storage available attached to a renewable power project, which is definitely much more expensive. So that would mean an incremental in the cost aspect. So the cost will definitely go up. So for the intermittent renewable powers, PEM is the most ideal technology at the moment. Moving on to the financial viability part, how much does it cost as of today to produce green hydrogen? The substantial part of the green hydrogen cost is taken up by the renewable power. Even if we are talking about the renewable power costs have fallen down, it is making sense today because of the cost of renewable power, yet the cost is very high if we compare it with the alternative that is available in the market, which is the gray hydrogen. So the gray hydrogen is about US dollars, $3 per kg, and green hydrogen is about $7 per kg. So about $6 per kg is renewable power, which is half of it is power production, and the other half is the power transmission. So the power transmission, the grid charges in India are very high. to produce power in one point and to take it to the point of consumption would incur a high cost of grid charges. And that's where the most of the scope of cost reduction also lies. About $3 per kg can be easily reduced through subsidies by government, by incentives. If there are incentives available to reduce at $3 per kg, the cost can come down significantly about to $4 per kg, and that will make it much more competitive to gray hydrogen. Also, considering that there is a much more fluctuation in the cost of fuel in gray hydrogen, natural gas, the costs are very much volatile there, and which is why consumers are today considering the alternative of green hydrogen against the gray hydrogen. But for that, there has to be a reduction in the grid charges part to make it financially viable. The electrolyzer capex and the opex part would definitely the cost reduction possible there only through technology advancements and through economies of scale. So as with time, there will be more research and development, there would be technology improvements. The cost of the capex and the opex would definitely come down and it will become more viable. So right now, as of today, it is definitely not at all commercially viable. It may be technology viable, but commercially, it does not make sense for consumers to adopt green hydrogen as of today. Looking at the government initiatives, if because we are saying that the economic viability is not there, are the government initiatives enough to help the market take off the ground? So there is a special subsidy given for electrolyzer production and green hydrogen. So talking about the green hydrogen production part, there is 54,000 crores of subsidy allocated for green hydrogen production, which will be disbursed over a 3-year period. So if we consider that the plant would definitely typically work around for 10 years, because that's the lifespan of electrolyzer technology, if we consider it to be across 10-year period, the effective subsidy available today is only 15 cents per kg. So that is definitely much lower than what the cost, what are the incentives available in other countries like EU, UK, where the incentives are about $4 per kg available for a 10-year period, or EU where there is a $4.34 per kg incentive available for 10-year period. So for 3-year period, for a 10-year period in India, in comparative terms, it is only 15 cents per kg. So it does not make sense. It does not lead to any cost reduction. And even if you look at the other part, the electrolyzer manufacturing, about 22,000 crores of subsidies is allocated. But if you look at the impact is only less than 10% of the cost of electrolyzers would be really reduced through this subsidy. So the total effect of all the subsidies would be very minimal to really move the needle, to really make an impact. So there is no material impact of the subsidies that are available in the country as of today. The other parts of the government initiatives is about, for example, green hydrogen standards. So it says about the emissions related to green hydrogen production should not exceed 2 kg CO2 per kg of hydrogen, which is definitely much more lax. So it will be easier for producers in India to produce green hydrogen as compared to export it to other countries, which have definitely much more strict standards. So here it is very important to note that the renewable power related emissions are not counted in India. So if any producers are looking for export market and really looking for export opportunities, today you cannot ship the green hydrogen that is classified as green in India to other countries, because it won't be classified as green in other countries because of how lax and relaxed and lenient standards available are in India right now. So definitely the standards would have to be tightened and made more stringent to make it more viable and to take it to the same global standards of green hydrogen in the future. There are definitely some grid charge waivers available which are available for green hydrogen production and green ammonia production, which are substantial. The cost will definitely reduce down to $1 per kg from the grid charges from $3, but the other $1 per kg cost would definitely still make it only viable to $5 per kg, which is still much more than the gray hydrogen cost. There are other initiatives also by states which are available, but they are yet to be formalized, yet to be notified. So we don't know if there is any material impact that can be that can really result through these government initiatives. So to just coming down to the policy discussion, policy recommendation, what is required? They are required to be much more incentives in terms of subsidies available needed for the green hydrogen production and electrolyzer manufacturing. There is there is need for incentives and grid charges waiver. There is a need for consumption mandates. Even if the green hydrogen producers are producing, the consumers would not adopt it unless there are mandatory obligation for them to adopt, which also happened in renewable power. There was an RPO that was issued, and that's when really helped the market to start using renewable power. So there is need for demand creation, demand side incentives like mandates on the key consumers like refineries and fertilizers to start using green hydrogen. Because of the substantial amount of renewable capacity that has to be built, all the issues in the renewable sectors would have to be ironed out and addressed for the industries to be able to set up more plants. There is definitely much more need for domestic manufacturing capacity for electrolyzers. We have missed the boat with module manufacturing, but for electrolyzer manufacturing capacity, there is much more time. We should not let India to be continue to depend on China's imports like we are today for module imports. There is need so that we should start right now to build the domestic manufacturing capacity, and for that there needs to be a lot many incentives and subsidies. Right now what is available is not going to create any material impact. And then the execution of the R&D plan, make sure there are technology advancements, there are demonstration projects to convince the industries that green hydrogen has a strong use case, and there needs to be also skill development and capacity building to ensure there is an army of skilled workforce available to support this ecosystem in the future. So there is undoubtedly a big role that can green hydrogen play in the decarbonization journey of industries and also in India. The market is extremely hopeful and very, very enthusiastic about green hydrogen, but it is still a few years away. Technology wise, we're still ready, but there's not enough domestic manufacturing capacity. There needs to be a commercial viability, domestic manufacturing capacity. The incentives available in the country right now are not going to create any change, any impact. So there needs to be a much more comprehensive support by the government that needs to be available. And very importantly, demand side incentives like mandatory obligation on refineries and fertilizers, which will help the green hydrogen market take off the ground. And with those thoughts, I would like to end my presentation here. Thank you so much for everyone for listening and patiently sitting through my presentation. Thank you.